Imagine sending a robot, a satellite, or even an entire spacecraft millions of kilometers away, and then asking it to wait for instructions from Earth every time something changes. That is the old way of thinking about space missions. But now, artificial intelligence is starting to change that. In this video, we're looking at how AI is reshaping space, from satellites that can think before they send data home, to Mars rovers that drive themselves, to future lunar bases that may need smart systems just to survive. NASA describes AI as a tool already being used across missions, Moon and Mars exploration, weather, mission planning, satellite imagery, autonomous vehicles, and more. So this is not science fiction anymore. This is becoming part of the real space industry. So first, let's understand why space needs AI in the first place. Space has a human speed problem. Here on Earth, we are used to instant control. You click, you command, something responds. But space does not work like that. A rover on Mars cannot be driven like a remote control car. A satellite flying over Earth may only have a short window to collect important data, and mission teams can be flooded with more images, signals, and sensor readings than humans can quickly analyze. That is why AI matters. It helps spacecraft and ground teams make faster decisions. Not because AI replaces scientists or engineers, but because it can handle the fast, repetitive, data-heavy tasks that slow missions down. The big idea is simple. Humans set the goals, but AI helps the mission react faster. And one of the clearest examples is happening right above us, inside satellites. Hot topic number 1, AI satellites. Traditionally, a satellite collects images, sends them back to Earth, and then computers or people analyze them on the ground. But what if the satellite could understand some of that data before sending it home? That is the idea behind onboard AI, also called Edge AI in orbit. Instead of downlinking every single image, including cloudy, useless, or low-priority ones, the satellite can filter, compress, and prioritize the data. ESA Sat-2 is a great example. It uses onboard algorithms to process and compress Earth observation images, detect wildfires, ships, marine pollution, and even select clear images while discarding cloud-covered ones. That means the spacecraft is not just collecting data, it is beginning to make useful decisions in space. And once satellites get smarter, the next question is, how can that help us here on Earth? AI in space is not only about exploring other planets. It is also about understanding our own planet faster. Every day, satellites observe storms, floods, wildfires, crops, oceans, cities, and climate patterns. But the challenge is turning all that raw data into decisions that people can actually use. NASA and IBM have worked on open-source AI foundation models trained on NASA satellite data. These models can support applications like flood risk identification, crop yield prediction, and long-range atmospheric weather forecasting. NASA has also used AI with satellite images to study things like blue tarps on rooftops after hurricanes, which can help estimate damage in affected communities. So you can think of AI as the planet's search engine. Instead of asking, where is the data? We can start asking, what changed, where did it happen, and who needs to know right now? Now let's leave Earth orbit and go to Mars, where AI is helping rovers move like explorers. Hot topic number 3, self-driving rovers. Driving on Mars is incredibly difficult. The terrain is unknown, the rocks are sharp, the slopes can be dangerous, and the communication delay means no one on Earth can drive the rover in real time. That is where autonomous navigation comes in. NASA's Perseverance rover uses AutoNav, a self-driving system that lets the rover analyze the terrain, identify hazards, and choose a safer path forward. NASA says Perseverance has done 88% of its driving autonomously. The rover takes images with its cameras, studies the terrain with onboard computers, avoids obstacles, and keeps moving through places no human has ever seen before. This is a huge deal because every extra hour spent driving is an hour not spent doing science. When the rover can move more efficiently, scientists can reach more targets, collect better samples, and explore more of Mars. But one smart rover is only the beginning. What happens when many spacecraft start working together? Hot topic number 4, satellite swarms. A single satellite can only observe one place at one time, but a swarm of satellites can share the workload. Imagine a group of small spacecraft that can talk to each other, divide tasks, and decide together what to observe next. NASA's Distributed Spacecraft Autonomy project is exploring exactly this idea. NASA describes software that can help spacecraft swarms navigate, complete science objectives, share perspectives, assign tasks, and adapt with less human intervention. The Starlink mission uses a group of 4 small satellites as an in-space testbed for autonomous swarm operations. This could become extremely important for future missions around the Moon, Mars, or deep space, places where constant control from Earth is slow, expensive, or simply impossible. But more satellites also create a new problem: space traffic. Hot topic number 5. Space traffic. Orbit is becoming crowded. Satellites are essential for communication, navigation, internet, weather, banking, disaster response, and national security. But the more objects we put into orbit, the harder it becomes to keep everything safe. ESA's space environment statistics were last updated on April 21, 2026. ESA lists about 15,200 functioning satellites and about 44,870 cataloged space objects regularly tracked by surveillance networks. That is a massive traffic management challenge. AI cannot magically remove space debris, but it can help operators analyze risk, predict close approaches, prioritize alerts, and plan safer maneuvers. Think of it like air traffic control, except the vehicles are moving around Earth at orbital speeds, and even a small piece of debris can cause major damage. AI is not only helping spacecraft operate, it is also changing how spacecraft are designed. Hot topic number 6. AI-designed spacecraft. When humans design spacecraft parts, we often create shapes that are clean, symmetrical, and familiar. But when an algorithm designs a part, it does not care what looks normal. It cares about constraints. Where does the part connect? How much weight can it carry? Where are the bolts? What areas must stay open? How can we make it lighter without making it weaker? NASA Goddard has shown mission hardware designed with AI-assisted generative design. NASA says these structures can look strange or organic, but they can weigh less, tolerate higher structural loads, and take far less time to develop compared with traditional methods. So these weird-looking parts are not just futuristic art. They are what happens when algorithms sketch first, and humans engineer the final result. But before we get too excited, there is a serious catch. This is the part of the story we have to take seriously: trust. AI in space is exciting, but space is not a normal software environment. You cannot just reboot a spacecraft whenever something goes wrong. You cannot easily send a repair team. And a small mistake can cost years of work, millions of dollars, or an entire mission. That means AI systems in space need to be tested against edge cases. They need to be explainable enough for engineers to understand their decisions. They need to be secure so commands cannot be manipulated. And they need human override, because mission responsibility still belongs to people. So the future is not AI replaces mission control. The future is mission control gets smarter tools. Humans still set the mission. AI helps manage the complexity. So what could this look like in the 2030s? Now let's zoom out. The future of AI in space is not one smart satellite or one self-driving rover. It is a full stack of autonomy. At the smallest level, AI helps design stronger and lighter parts. Inside spacecraft, AI helps manage systems, power, data, and navigation. Across satellite networks, AI helps swarms coordinate. In mission control, AI helps teams search through data and respond faster. And in science, AI helps researchers find patterns that would take humans much longer to detect. For future lunar bases, this could mean smart power systems, autonomous maintenance, robotic construction crews, and AI science co-pilots. For Mars, it could mean scouts that map terrain, identify hazards, and help choose the best places to explore. The deeper we go into space, the more autonomy becomes infrastructure, not a bonus feature, a requirement. And that brings us to the biggest question of the whole video. So here is the big question. How much autonomy do we actually trust beyond Earth? AI can help us explore farther, react faster, and understand more data than ever before. But the farther we go, the more important responsibility becomes. We need smart machines, but we also need verification, transparency, safety, and human judgment. So I want to ask you, would you ride in an AI-assisted spacecraft? Would you trust an autonomous rover to choose the best path on Mars? Would you trust a satellite swarm to make decisions without waiting for Earth? Drop your answer in the comments. And if you enjoyed this video, like, subscribe, and tell me what space and AI topic you want next. Next episode idea. Can AI help build a moon base?